Hi guys, welcome back to Mathematics for Engineering 3 for students at Kasetsart University International Program. Okay, in the previous section, we talked about the integrating factors, right? In this section, we're gonna talk about a linear equation of order 1. Okay, but we're gonna need the integrating factor. So if you don't understand the integrating factor, go back and look at the integrating factor, okay, but because we're gonna need it, okay. So let's start first. Okay guys, first let's look at the form linear equation of order 1. So here, if you have dy by dx, function of x, y and qy, that is called a linear equation of order 1 in dependent variable y. So basically means that y is a dependent variable. If you go back to the lecture 1, right, when we talked about the introduction of ODEs, we talk about dependent and independent variables, right? We know that y here, if we have dy by dx, the y here is a dependent variable and x here is a independent variable, right? So here, you know how to recognize that it is a linear equation. First, you need to look at the y there. Okay, you can see that the y is y to the power of 1. That indicates the linearity, okay? And another thing is here, which is dy by dx. You have dy by dx and y. And the rest, they are function of x. See? So it seems like you have derivative plus function of x, y equals function of x. See? And this is the same as this because dy by dx is y prime, isn't it? Right? And the next one is the same as you multiply the whole equation by dx. Okay? So this dx cancel out and you have dx here and dx here. Guys, again, I told you many times that mathematically that's not right, okay? You can't really multiply the equation by dx. That's not okay, it's not correct mathematically, but you can still do it, okay? It's the easy way of doing it, but just just remember that it's not mathematically correct. Okay, if you want to be rigorous, to be really mathematically correct, you need to look at it as a differential form. Okay, but anyway, here, so these and these are equivalent. Okay, they are equivalent. So here we have dy and function of x, y dx, qx dx. Okay, we have dy, function of x, y dx, function of x qx, function of x dx. Okay, so basically, to be a linear equation in the dependent variable y, you have only one y here and dy here. That's it. The rest are function of x. Okay. The next one is the linear equation of order 1 in the dependent variable x. So it's the same thing. It just swap between x and y. So we have the x by dy and we have x here. See? So we have one x here and we have the x by dy. And the rest are just function of y. And in the differential form, we have x here, the x here, and the rest are function of y. Okay, so to be a linear equation, okay, first case, when in the dependent variable y, we have that dy sum x, y dx sum x. Okay, and the other one would be dx by dy, or you can look at this dx sum y x dy f function of y dy. Okay, so you need to be able to recognize this form, because if you see equations, you need to be able to tell that it's actually a linear equation of order 1, so that we can use technique in this section to solve the problems. Okay, so the most important thing is that you need to be able to recognize, okay, which equation is a linear equation of order 1. Okay, so now if you can recognize that this equation is actually linear and the order is 1, then we're gonna look at how to solve this particular type of question. Okay, so next let's have a look at how to solve this particular type, the linear equation of order 1. First, I will look at when the y is a dependent variable, which is the first case, right? So we have that. We have y here, we have dy here, and the rest are x, qx, dx, right? So first, I just move this to this side, and that should be easy, shouldn't it? Right? So it's px y dx is pxy minus qx and then dx. Okay? Plus dy equals 0. Okay? pxy minus qx dx plus dy equals 0. And you can see that 1 over n dm by dy minus dn by dx is, we just have a look. N is, guys, here m is pxy minus qx, right? And n is just 1, isn't it? Right? So the derivative of m by y would be just px, isn't it? Because you take the derivative by y. So here is y to the power of 1. So it becomes 1, right? So you get px, and the derivative of this is 0. You take the derivative of y, don't forget. So the x is seen as a constant. Okay? So x is considered as a constant. So we have what is it? 1 over 1, right? Because n is 1. 1 over 1. dm by dy is px. dn by dx, but n is 1. So dn by dx is 0. Right? dn by dx is actually 0. So this guy is nothing but just px, which is a function of x. So if you remember, we go back to the previous section, right? If you don't, I have it here, the take-home message from the previous section. If this guy is a function of x, we have mu defined by e to the integrate fx dx is an integrating factor. Okay? So in this case, we have that mu is actually what? Mu is actually a e to the integrate px dx, right? Right? Because this guy is actually fx, right? So the integrate of e integrate fx dx is actually e integrate px dx. And note that. So guys, right now it becomes, it's the same as the previous section. We can find the integrating factor, right? So we can multiply the integrating factor to this equation, and then it becomes exact. Okay. We're gonna do that. But we're gonna do it even smarter. We're not gonna do it as in the previous section. In the previous section, you can notice that one question is so long, right? Because first we have to compute the integrating factor, and then we need to multiply the whole equation here by the integrating factor. And after that, we need to solve that by using the exact equation approach, right? To have df by dx and df by dy, and then we integrate, differentiate, and compare, right? But if the equation is linear, we don't need to do that. That's a great news. Okay, that's a great news. Why? Because if you notice, what is d mu? What is d mu? D mu is mu is this guy, right? It's exponential, right? So if you look at this as u, right, I'm gonna use the chain rule. Okay, so d of e to the u is actually e to the u, and then differentiate this guy is px dx, right? So I can say that it's actually mu px dx, right? It's mu px dx, and then I multiply mu to to this equation, to the equation star. Okay, so this is the equation that I get, and right now I know that this equation is exact, but I'm not going to use the direct approach. Okay, I'm not going to get the df by dx and then integrate, differentiate, and compare. I'm not going to do that, because if the equation is linear, we can do it easier. Okay, how? If you look here, so when we multiply mu to this equation, we get this, right? Okay. So guys, d mu y is actually mu qx dx. No, it's actually not. What is d mu y? Sorry, my bad. What is d mu y? Let me change this a bit. Okay, I'll just wing it. So here is mu dy. Okay, I get it from here. Make sense? And guys, plus y d mu. Can I write it that way? Because guys, if you look here, d mu is actually mu px dx, right? So I have mu px dx. So this guy is actually d mu, right? So it becomes y d mu. Okay, and mu dy plus my y d mu is what? It's actually d of mu y. Okay. So I have that this guy is actually mu y, d mu y equals mu qx dx. Okay. So the solution would be, you just integrate this equation and then you plus c. Okay, so you have that mu y equals integrate mu qx dx plus c. And once you integrate this function, it's all done. Okay, it's all done. Okay, don't forget guys, mu is a function of x. Okay, mu is a function of x, so this is only function of x. So if you can integrate this function, it's all done. Okay, let me summarize it again guys. First, you look at this equation, which is a linear equation of order 1, and you can see that 1 over n of this guy is actually px, is this, and is a function of x, which means that mu, the integrating factor, can be defined in this way, e to the integrate px dx. And if you notice, d mu is actually this guy. Okay, so once I multiply mu to this equation, to the star equation, I get this guy. But I know that this equation is actually exact. Okay, because I multiply it by the integrating factor, right? So it must become exact. But instead of using, the direct approach, the f by dx and then integrate, differentiate, and compare, I'm not going to do that. What I am going to do is that I'm going to observe here. I see that this is mu dy. But mu px dx is actually d mu. So I have to the left, from the left hand side, it's actually mu dy plus y d mu. And that thing is actually d mu y, right? Because d of uv is u dv plus v du, right? So we have that the left hand side is actually d mu y equals mu qx dx, and then you integrate throughout the equality, right? The equation, and then you have the constant here. So the integrate and the differentiate, they cancel out. So you have mu y equals this guy, and once you can integrate this, it's all done. Okay. And guys, the case for dependent variable x is pretty similar. Okay, now let's say that we have x here, dx here, and this is py dy, qy dy. Okay, and then I just move this to this side, so I have dx and pyx minus qy, and then dy. Okay, I just move this to the left hand side, equals 0. Okay, and then I look at 1 over m, dm by dy minus dn by dx. Okay guys, let's look here. In this case, m is 1 and n is pyx minus qy. So we have that dm by dy is 0 and dn by dx is actually py. Okay, so 1 over m is going to be just 1 over 1, and dm by dy is 0 minus dn by dx, which is py. So we have minus py, and we let this be what is it? I don't remember. Gy. Okay, we let that be gy. Okay, and the integrating factor is a function of y, isn't it? It's a function of y. So the integrating factor is e to the minus of integrate of gy. Right? If you don't remember, you go back and see here. It's the minus of integrate of gy dy. But gy is minus py. So here is e to the integrate minus of minus py dy. So minus and minus cancel out. So we have mu is actually e to the integrate py dy. Okay. And guys, d mu, what is d mu? It's the same thing. It's e to the, what is it? E to the integrate py dy py dy, which is mu py dy. Okay, it's mu py dy. Okay, guys, don't forget mu is e to the py dy, right? So if you want to find d mu, is you want to find the e to the u. Okay, so it's e to the u du by dy, and then you have dy here, right? So then we have mu, right? We multiply mu to this equation, so we get this equation, and we know that this equation is exact, right, from the previous section. But we are not going to solve it using direct method. Okay, I'm not gonna have df by dx, integrate, differentiate, and compare. Not going to do that, because there's a faster way. Once the equation is linear, okay, it can be fast. It can be solved even faster. So guys, again, here is a typo. I'll just delete it out. So guys, mu dx plus again guys, if you look here, mu py dy, mu py dy, that is d mu, isn't it? That is d mu, isn't it? So it's the same as to say that x d mu, and that is d mu x. Okay, that is d mu x, which means that we have that d mu x is mu dy qy dy. And then if we integrate, we have plus a constant here. Okay, so we have that mu x equals integrate mu qy dy plus c. Okay, once you can integrate this, it's all done. Okay, so let's look at the take-home message. Okay, one of the most important page on on this section. First, when you see linear equation, this is the we have y dy, right? Let me color it. We have y dy or x dx, right? If we have y here, the rest are x. See? If we have x here, the rest are y. See? So the integrating factor for this one would be e to the integrate px dx. So you basically is e to the integrate things in front of y. See? And here is e to the integrate things in front of x. Okay, and that's easy to remember. Okay, so mu is e to the integrate thing in front of y. Here is integrate e to the power of integrate things in front of x. Okay, and once you get this mu, you multiply mu, you multiply mu to the equation, right? And then don't forget that mu dy and mu px y dx, right? You multiply mu to this side. That is actually d mu y, right? And that is the same, right? You just multiply it by mu. And similarly, for this one, when you multiply it by mu, don't forget that mu dx plus mu pyx dy is actually d mu x. Okay, and then after that you can just integrate. throughout the equation and you plus c and you obtain the solution. Okay, okay, okay. So let's look at some example. Okay guys, if you look at this question, you can see you have dy here, right? And you have 1y here. And the rest is x, right? So first you need to be able to tell if it's a linear equation. Okay? So if you can't, there's nothing else you can do. So here, what I'll do is that I will write x dy. Okay, I'll move this to the front. Okay, x dy, and then it will be plus 2y dx, and minus 8x squared dx equals 0. And then it will be x dy plus 2y dx, minus let's say equals 8x squared dx. Okay, and then I divide the whole thing by x, so I get dy plus 2 divided by x y dx equals 8x dx. And see, I have here y dy, and this is actually what you call px, and this is actually what you call qx. Okay, but you don't need to care about that. Okay, so in that case I know that mu is, what is it? What is mu? Mu is e to the integrate thing in front of y, right? In front of the, you know, the y term. Okay, so is 2 over x. You don't need to remember it as a y term, but you know, you look at it as the second term. Okay, thing in front of the second term. Okay, that's easier to remember. So is e to the integrate 2 over x dx. Okay, and that is actually e to the 2 integrate 1 over x dx, which is e to the 2 log absolute x, which is e to the 2, or no, log of absolute x squared, and this cancel out, so you get absolute x squared, which is actually x squared, because x squared is always positive. You don't need absolute. Okay, and then don't forget guys, what is d mu? d mu is actually e, let me move it a little bit down here. d mu is actually what? E to the, I won't look at this one. You can look at that one, it's 2x, but it's gonna be much harder. If you look at this one, it's gonna be much harder later on. So if I were you guys, I would just look at this one. So d mu would be what? E to the integrate 2 over x dx, and then 2 over x dx. Right, that is d mu. Okay, and then, right, if you differentiate e to the u, right, e to the u, you get e to the u du by dx, and then you get dx here, right, so you have e to the u du by dx. You differentiate the integral, so the integral and the derivative cancel out, so you have 2 over x, and then you have dx. Okay, or you can write it as mu 2 over x dx. Okay, after that I multiply equation star sorry, I multiply equation star with mu. Okay, so what I have is, let me look at this as equation star. So let's call this equation double star. Okay, So I'll multiply the equation double star. I think it's easier with mu, because this star and double star, they are the same equation, but this looks, it looks more friendly. Okay, so when I multiply that to mu to the equation double star, what I have is mu dy plus mu 2 over x y dx equals 8x dx. Okay, and then guys, as I told you, see, the mu is mu 2 over x dx, so you have mu 2 over x dx. So this guy is actually mu dy plus y d mu equals to 8x dx. Okay, oh, you have mu here as well, because you multiply mu to the whole equation, right? So you have d mu y equals mu 8x dx. Okay, but mu, what is mu? Mu is x squared, and then you substitute mu but with x squared, and that is actually 8x cubed dx, and then you integrate this plus c. So what you have is x squared y equals 8x to the power of 4 divided by 4 plus c. So it's 2 squared y, x squared y to x to the power of 4 plus c, and that is the solution. Oops. And that is the solution, which is pretty easy, isn't it? Okay. Let me wrap it up. First, you have an equation. You need to be able to tell that it's actually a linear equation. So, you rearrange the term, you end up here, which you have dy and y. And as I told you before, mu is actually e to the integrate this one, dx. Okay, the thing in front of y here, dx. And then you integrate that, you have x squared as mu. And don't forget, guys, d mu is this guy. Okay, after that, you have this, right? You multiply mu to this equation. And then you know that this guy is actually d mu y. Okay, you don't need to have, to do the df by dx and then, integrate, differentiate, and compare. No, you don't need to do that. Okay, even if you know that this equation is an exact equation, you don't need to do that. Okay, and then you integrate, so this cancel out, see, and you have this as the solution. Guys, it looks simple what I'm doing, but I highly recommend you guys to do it yourself many times. Otherwise, you're gonna get stuck somewhere. Okay, so the step is that first you get the term, get the equation, get it in the proper form. That's the first step. The second step is that to find the integrating factor, right? The third step is that to find the d of integrating factor. Don't forget the third step, it's pretty important, okay? And the fourth one is to multiply mu to the equation number 1, right? The equation double star. And after that, this is the fifth one, which is to turn the left hand side here into d mu y. right? And then you integrate to find the solution. Okay, so there are many steps involved. Okay, so I highly recommend you guys to try it yourself. Okay, to try it yourself, and you're gonna see that it's not as simple as it seems. Okay, it's not as simple as it seems. So try it first. Okay, let's look at another question. So this question again, guys, I look here, I see dy here, and I have one y here and dx, right? And the rest seem to be the function of x. Okay, so again, I'll move the y to the front, so I get what? Minus 1 minus plus x squared dy. Okay, and then I have plus 2xy dx plus x dx equals 0. Okay, let me push it a little bit to the left hand side to ensure that I have enough space for the whole equation. Okay, see, and after that is I just move this guy to the right hand side. So what I have is minus 1 plus x squared dy plus 2xy dx plus equals minus x plus x cubed dx. See, and then I divide the whole equation by minus 1 plus x squared. So what I have is dy plus 2x divided by 1 plus x squared. I have minus, right? So can I just move minus here? Okay, and then I have it equals x to the power of 5 plus x cubed divided by 1 plus x squared dx. Okay, and after that I'll pull x squared out. No, I'll pull x cubed out, so I get x squared plus 1 divided by 1 plus x squared dx, and these are cancelled out. Make sense? Okay, so guys, sorry, I forgot the x here. Okay guys, so let me write it again. We have that is dy minus 2x divided by 1 plus x squared, and I also forgot y as well, sorry. Right, I should have y here as well, right? Okay, and in that case I have y here dx equals x cubed dx. So my integrating factor mu, right, that is the first step, right, to rearrange the equation. The second step is to find the integrating factor, which is e to the integrate, and it's the thing in front of y, right? So it's integrate minus 2x divided by 1 plus x squared dx. Okay, and that is actually e to the minus integrate 1 divided by 1 plus x squared d1 plus x squared. Guys, don't forget d1 plus x squared is actually 2x dx, right? Because the derivative of 2x x squared is 2x, and you have dx. Okay, so this is 2x dx, so you have these guys. Okay. So in that case, you have that mu is actually e to the minus log of what absolute 1 plus x squared. Okay. Which is e to the log of, you have minus here, right? You can put minus here over there. Okay, it's going to be this one to the power of minus 1. Right? Which is log of 1 divided by 1 plus x squared absolute. Okay. Right? You push this, so it's minus 1. And then because the exponent is minus 1, so it is pushed down. Right? So what we have here, this cancel out. So mu is 1 divided by 1 plus x squared absolute. But guys, x squared is positive. X squared is positive. X squared plus 1 is still positive. So I can get rid of the absolute. So it's 1 plus x squared, like that. Okay? And that is the second step. The third step is to find d mu, right? I always do that as well, right? D mu. D mu is what? Because mu is this guy. So d mu is actually e to the integrate minus 2x 1 plus x squared dx times minus 2x divided by 1 plus x squared dx, which is mu times minus 2x divided by 1 plus x squared dx. That is d mu. Okay, and then the fourth step is to multiply mu to this equation, right? So what we have is, what is it? We have mu dy minus mu 2x divided by 1 plus x squared y dy equals mu x cubed dx. Right? Guys, look at this, okay? This one. X cubed. Okay, this cancel out already. So we have x cubed dx. Okay, but again guys, because what we did here, we see that d mu is actually this guy. So we have that mu dy minus mu minus 2x divided by 1 plus x squared dy is actually what? Sorry guys, this one is dx. My bad. Okay, this one is dx. Okay, it's actually what? It's actually d mu, isn't it? So we have y d mu equals mu x cubed dx. So we have the mu y equals mu x cubed dx, but mu is 1 over 1 plus x squared. So we have that is d of 1 over 1 plus x squared y equals 1 over 1 plus x squared x cubed dx, and then you integrate this guy and you plus c. Okay, so you have that 1 plus x squared 1 divided by 1 plus x squared y equals integrate integrate x cubed divided by 1 plus x squared dx plus c. Okay, but you still need to integrate this one. I think I believe that you know how to integrate it, right? That would be what the lecturer love to say, right? And let you integrate it yourself. And it turns out that you can't really integrate it. Right? Right, you're not the first year, right? So you know what, how we the lecturer really are, right? So we let you guys, you can know integrate, you can integrate it, so you integrate yourself, and then it turns out that you don't really know how to integrate it. But I really believe that you can integrate it, okay? But I just want to make sure that you know you don't forget how to integrate it. So I'll look at this guy. X cubed is actually x 1 plus x squared minus x, isn't it? Isn't it? Right? Here, this one. If the exponent here is higher than the highest exponent here, you need to do the division. Okay, but I'm not going to do that. I can do this simple trick. It's easier. But if you don't know how to do this, you just do the division. Just divide x cubed by 1 plus x squared. Okay. So what I have here is 1 divided by, let's use the black ink. So 1 plus x squared y equals that would be integrate of x 1 plus x squared minus x divided by 1 plus x squared dx plus c. So what we have here is integrate x 1 plus x squared 1 plus x squared minus x divided by 1 plus x squared plus c. Oh, sorry. Dx plus c. And these cancel out. So you actually have x squared divided by 2. Right? Minus, well, that is, can I do this? Can I do this? Can multiply this by 2 and divide it by 2. Okay? I multiply it by 2 and then I divide it by 2. Okay? That would be 1/2. Okay? Integrate of 1 over 1 plus x squared d 1 plus x squared plus c. Why? Guys, don't forget, guys. D 1 plus x squared is actually 2x dx. So this is 2x dx. So it becomes d 1 plus x squared. Okay. Okay. And you still have, 2 here. Cool. So the integrate of that would be, what is it? X squared divided by 2 minus 1/2 of log of 1 plus x squared plus c. And that is the answer. Okay, that is the solution. Okay, that is the solution. Make sense? Okay. So let's look at another example. Solve the equation, this equation. So guys, this one is a little bit different. Why? Because if you look here, you have the x and you have 1x here. Oops, you have 2x here. But you can pull it out. You can pull it out, right? You can pull it out. Okay, okay. So it's actually the second case when we have a linear equation when x is a dependent variable. So I'll just keep this here. Okay, so I have, what is it? Y dx, and then I have plus 3x minus xy dy plus 2 dy equals 0. Okay, and then we have that is y dx plus what is it? 3 minus y x dy plus 2. Oops, I'll just move it to the other side. So it's minus 2 dy. Okay, and then I divide the whole equation by y. So I have dy plus 3 minus y divided by y x dy equals minus 2 divided by y dy. So guys, you can see now, right? It's x. Oops. Here's the x. Sorry. X dx. And then the rest are just functions of y. Okay. Okay. Cool. So that is the first step. The second step is to determine the integrating factor. And that is easy as well. It's e to the integrate. And that will be things in front of x, right? See? I tell you, it's pretty simple. It's just, the coefficient of the second term, this one. Okay? In the previous one, here is y, right? So you take this in here. And similarly, here is x. So it's the same, you just take this in here. Okay? So that's why I say it's really simple. If you keep doing exercises, you're going to be really familiar with it. Okay? It's going to come automatically. Okay, so what you have is 3 minus y dy divided by y dy. Okay, and that is actually what e to the integrate 3 divided by y minus 1 dy. Right? So what you have here is e to the that will be 3 log y, log absolute y minus y. Okay, and this is a great trick. Okay, so here is e to the log of absolute y cubed. Okay, it's nothing, I just push this up here. Makes sense? So I have log absolute y cubed. Okay, and here minus y. Can I say that it is actually plus of log of e to the minus y? Can I do that? Of course, yes, because they would cancel out, right? And we have minus y back. Makes sense? We have log of exponential, so they basically cancel out. So we have minus y back. The reason I do that, the reason I did it because I'm gonna combine this log, so it's gonna be log of, what is it? Absolute y cubed e to the minus y, right? Because log of a, right, you have that log of a plus log of b is actually log of ab, right? You can multiply it there, right? Like that from high school. So again, guys, these cancel out. So you have that is actually absolute y cubed e to the minus y. Okay, and then the third step, again guys, is to find, what is it? D mu, right? D mu is actually, I think you guys are already familiar with it, right? You just use this one, right? D mu is what? Is e to the integrate 3 minus y divided by y, and 3 minus y divided by y dy, right? And that is actually mu 3 minus y divided by y dy. Okay, and that's done. Fourth, you multiply mu to the equation star, which is this one. Okay, you multiply mu to the equation. So what you have is mu dx plus mu 3 minus y divided by yx dy equals minus 2 divided by y dy. Oops, sorry, dy. Oops, again, I forgot mu again. Sorry. Such a bad student. I'm just gonna erase it, okay? And I write it again. So it's gonna be minus 2 mu dy divided by y, okay? Okay. Okay. Oh. Well. Our mu now is It's tricky here, but it's the same trick. Our mu is, this one, right? Absolute of y cubed times e to the minus y. So it can be, y cubed e to the minus y and minus y cubed e to the minus y. Right? This is when y is non-negative, and this is why when y is negative. Right? Right? Because absolute, it can be positive and negative. But guys, if I multiply this to this equation, or I multiply this to this equation, they are the same. It's the same as, the reason is the same as in the previous section, in the previous video. The answer is that because the minus here, I can multiply the whole equation by minus. Right? And that's why you just need to use one of them. Okay? So I will just choose mu equals y e to the minus y, like that. Okay, I'm not going to use the negative one. Okay, you can just get rid of the negative one, because they are the same. When you multiply the whole equation by either positive or negative, they are the same, because you can multiply the whole equation by negative by minus 1 again, right? And they turn to be the same. Okay, so just pick one, just use one of them, and use the positive one is a little easier, isn't it? Okay, so I'll continue from here. Okay, so what I have is, what is it? Mu dx, and then guys, again it's the same, right? It's repetitive, right? I keep doing the same things. Here is mu this and that, and that is actually d mu. So I have plus x d mu equals minus 2 mu dy divided by y. Okay, and I have that is d mu x equals minus 2 mu divided by y dy, right? And then what I do is that I put mu in there. So what is mu? Mu is y cubed dy cubed e to the minus y x equals minus 2 y cubed e to the minus y divided by y dy, right? And this cancel out, you get y squared, and then you integrate throughout the equation. Okay, so let me copy this to the next page. Each question seems to be really long, right? Oops, what's that? Okay. Okay, guys, this is what we have. Okay, so this is actually cancel out, right? So we have y cubed e to the minus y x. Okay, y cubed e to the minus y x, and then the left hand side is integrate. Wow. Minus 2 integrate y squared e to the minus y dy plus c. Okay, and can I write it that way? It's integrate minus y squared. Y squared and minus y squared are the same thing, right? And then e to the minus y d minus y. Guys, don't forget d minus y is actually minus dy. Okay, so I have minus dy. So here I I only have 2 left. Okay, plus c, and then I let w be minus y. So what I have here is to integrate w square e to the w dw plus c. Okay, and for that one we need to do integration by parts twice. Okay, we need to do integration by parts twice, but I'm not going to do that. Okay, I'm going to use the shortcut, the one that I told you guys before. So the shortcut is that we have u and dv, right? And u is w squared, dv is dw, e to the w, and we have 2w, 2 and 0, e to the w, e to the w, e to the w, and then we do it this way. We have plus, minus, plus. Okay, so the integration would be 2 times w squared e to the w, right? This is plus, minus, plus. Okay, and then minus 2w e to the w plus 2 e to the w, and then plus c. Okay, and then if I pull 2 e to the w out, I get w squared minus 2w plus 2 plus c. Okay, so the solution is y cubed e to the minus y x equals to e to the w. What is w? Minus y, isn't it? Minus y, isn't it? So it's e to the minus y. W squared is the same as y squared plus 2y plus 2 plus c, and that is the answer. Okay, that is the solution. Okay. Oh, the next question, I'll let it be the exercise. So you try doing it yourself, okay? And if you can't do it, we can talk about that in the live class. Okay, we're gonna have live class as well, right, on Monday. So we're gonna talk about that on live in the live class if you have problems with it. Okay. So that's it for this section. So just to sum it up, we talked about the linear equation, right? Which can be in either this form or this form. Okay, this is when y is the dependent variable, and here when x is a dependent variable. Okay, and we have y dy, the rest are x dx, the rest are y. Okay, and if you can identify that it is a linear equation, the way to solve it is that first you get the integrating factors, right? For this case is e to the integrate of the things in front of y, dx, right? For this case it integrate of things in front of x here, dy. Okay, and then you multiply this to the equation, right? To the equation, and after that, don't forget, guys, that this is actually d mu y and d mu x. Otherwise, you need to have the df by dx, and then you integrate, differentiate, and compare, and that takes longer. Okay, that takes longer time. So just do this. It's quicker, right? As you notice, it's much quicker. Okay, and then you integrate, and you get the solutions. Okay, and that's it, guys. That's it. Guys, do lots of exercises. Okay, you're gonna be fine if you do lots of exercises. I understand that it's tough, it's so many forms, right? There's so many forms to study, there's so many things to remember, to memorize, but I'm trying to to make it easiest for you guys, as much as I can do. Okay, but you need to help yourself as well. So the way to master it is to do exercises. Okay, so if you do exercises, you came across any problems, I already sent you all exercises, right? Or relating exercises, just so do them, guys. And if you have any problems, just ask me, okay? And you're gonna get A. Okay, so you're not gonna have any problem with it. In the next video, we're gonna talk about a Bernoulli equation, which is actually can be kind of rearranged somehow to be a linear equation with other one. Okay, so guys, if you notice, things are connected, right? Things are connected, so you need to know one in order to know two, and then to know two to know three, and blah blah blah. So you need to keep practicing, guys, and keep looking at, watching the videos, okay? And then you're gonna be fine. Okay, see you in the next video. Bye bye, guys.